start with the flight control. So what is the basic benefit of fly-by-wire? क्या benefit क्या नहीं? क्या
weight redundancy, safer technology.
एक तो रखी है वैसे. So one of the important thing is feedback. Why feedback is important? Because the flight computer, the flight control computer, it takes the feedback based on your inputs. It is not applying the same amount of force on the control surfaces. Based on whatever the requirement is there, that requirement comes from the feedback. And once you receive the feedback, accordingly it acts. So there are n number of benefits, like less aircraft weight we can reduce because mechanical component. The moment we reduce the mechanical component, so the weight can be reduced. Ease, as a pilot perspective, you see it is very easy to do. Make aircraft extremely stable. So we can introduce certain laws. So with the help of those laws, the aircraft will be stable. The moment it is stable, it will be more safe. And that is availability of feedback. And there is a provision where we get the availability. Based on the feedback, the access will be taken by the flight control computer. Normally, pitch. Which surface is controlling pitch?
Elevator.
So in general, if you see the control surfaces, the elevators, MTHS, the rudder, the aileron, speed brakes, numbers are from this side or this side?
Inside.
So these are called 2, 3, 4, 5 are called low response. 2, 3, 4
Speed brakes.
So flaps and slats. Flaps, slats. Then the flight controls are basically electrically or mechanically controlled. Most of them are electrically controlled, but as per the requirement, some are mechanically controlled. So pitch axis is basically elevator and stabilizer is there. Elevator is purely electrical, whereas stabilizer is electrical for normal, right? And mechanical also for manual control. Roll axis, ailerons and spoilers are there, so both are electrical. Yaw axis, the rudder is there, is mechanical and electrical for yaw damping and turbo. Speed brakes are there, so those are electrically controlled. Then the cockpit control system, side stick. Each pilot has a side stick controller which to exercise manual control of pitch and roll. These are on the respective consoles. Two side stick controllers are not coupled mechanically. There is no direct mechanical connection between these two. And they send separate sets of signals to the flight tool. The side sticks are spring loaded to neutral. They are not mechanically linked and do not receive feedback from the flight control. So basically it is, in the later slide we will come to know how this is going. Suppose you give some input. You leave it. So will it retain or not?
Yes.
So because of certain laws and the movement of the other control surfaces, it will retain. It will try to retain to that level. Till the time you will change it. The moment you will change this, again it will take the input and it will change accordingly. When the autopilot is engaged, side sticks are locked in the neutral position. If a flight crew member applies a force above a given threshold, और आपके बंदे हैं क्या वो आर एस एस दो बजे से आया कितने लोग हैं आपके आज कितने होने लोग नहीं अगर मैं चाहता हूँ मैक्सिमम इंस्ट्रक्टर के लिए प्लान किया है मैंने तो अगर तो एक दो लोग आएंगे तो फिर कैंसिल कर देंगे ना तो ज़्यादा नहीं चलेगा हाँ हाँ ठीक है मैं बताता
हाँ मतलब जब नहीं होता तो पता चलेगा स्लाइड पे बोला नहीं था तो उसके बाद स्लाइड देखते हुए चला पर ऑटो फ्लाइट वाले ने ओरली बहुत तो उसके लिए डिले अभी फिर भी अभी हो जाएगा कुछ शायद
rudder, two pedals, internal control of the rudder, then the speed brakes, there is a lever on the center of the crystal. Whenever the lever is on or reverse thrust is selected, all the spoiler surface will automatically end at landing or in case of reversible takeoff. THS क्या हो गया? So previously THS is manually controlled on ground for the THS setting. Before takeoff and in flight within direct launch. Before takeoff, the pilot sets THS to the angular value determined as a function of the aircraft CG using the CG scale on the wing. The relationship between the aircraft CG and THS settings shown on the table is only a visual one. Basically, when they get a trim sheet, you know what is trim sheet? Trim sheet says the information to the pilot as well as the complete information of loading of the aircraft, where all the CG informations are there, center of gravity. So it includes the takeoff CG, max 0 fuel weight CG, landing CG, all the CG information will be there. And that has to be entered into the MCG. So you are preparing the aircraft for takeoff. You look the pre-flight things. First you check the trim set. Nowadays there are three different ways of CG representation. One is the manual. So the manual format is there, where a diagram of envelope will be there, the CG envelope. And there they will mention this is the CG, different CG, because CG, ME max 0 figure CG. The other format is the computerized FMC, where it will be in a computerized format, there will be no envelope shown over there, only the values will be there. Number of passenger, number of cargo, how much weight, and mortality is there, all these information will be there. Third one is the latest one is through ACARS. Through ACARS, the message will come to the cockpit and they will send you the preliminary one, the alerts, and once the pilot, if pilot feel there is a change, some changes will require, so they will inform the road checker. Accordingly, they will change and they will send you the final copy and it will be accepted by the pilot. Once it is accepted, that is to the accordingly, that has to be entered. Have everybody signed? Has everybody? So, during takeoff, with the help of that trim seat, they make the entry. In flight, there is no change. They are not using at all. Only during the takeoff phase, they make the entry by using the trim seat. Pitch trim wheel. The pilot use mechanically interconnected handwheels on each side of the center pedestal to control EHS. Both pitch trim wheels provide mechanical control of the EHS and have priority over electrical. So basically, normally electrically it is going on, but the moment you use it through mechanical, it has a priority to take over. Crew action under pitch trim wheel does not disconnect the elax. This we have to take care of it. The moment we are using it mechanically, it doesn't mean that it is not connected to elax. It will be still connected to the elax. Rudder trim. So with the help of this, we can select the rudder trim. Although then the slats and flaps, there are 5, 0, 1, 2, 3, 4. 1 plus F and 1. What is the difference between 1 and 1?
Flat.
So pilot use side stick to fly the aircraft in pitch and roll, and in yaw indirectly through control. So the flight control computer actually interprets the pilot input and use the flight control surfaces as necessary to follow them. Based on the feedback and other things, they will be acting as necessary. However, in normal law, regardless of the pilot input, the computer will prevent excessive maneuver and accidents of the same envelope in kitchen, irrespective of the other things. In the normal law, the envelope is protected in such a way that even if you try to give some excessive maneuver, the computer will not get. It will restrict to a certain limit, whatever is the defined envelope. Then the computers are there. So there are three total 7. So 3 elac, how many elacs? 2 elacs are there, 3 sacks are there, 2 flags are there. So elac is elevator, ground computer, sec is the cockpit, you can see the over there. The panel over it, you can see all those information, the left side and the right side. Then total there are 7 flight control computers. 2 are relaxed for normal elevator and stabilizer control and aileron control. 3 sets spoiler elevator computers for the spoiler elevator and stabilizer. And there are 2 facts basically for the rudder, electrical control of the rudder surface. In addition, there are 2 FCDC, flight control data concentrators are there. So this is basically for the display on the EIS and for the video maintenance. Sorry. You want it is there in the FCOM, I think.
Yes, sir.
All the information is there in the FCOM. I have taken it from the FCOM. Just what I have collated from different locations, I have put it in one place. It's there. So the two ELACs are installed. Normally only one ELAC is active. So in normal operation, one ELAC will be active, while the other ELAC serving as a backup in the event of a failure. So if any failure, it will switch over to the next. The active ELAC provides the control of the elevators, ANR, and the DHS. The ELAC function as the primary flight control computer, computing the need for the roll spoiler movement, which is sent to the set, and rudder yaw movement, which is sent to the fan. Either ELAC can provide complete control of the aileron, elevator, and DHS. Then six are there, three six. The three six directly control the spoilers. Unlike this ELAC is the complete. It controls everything completely. Whereas the set where the active computer controls both aileron, each set. ELAC, both aileron it can, but here in each set control only one or two pairs of spoilers. If a specific set fails, it is associated with spoiler. You know. Facts. The two facts primarily control the rudder. Normally only one fact is active, with the other serving as a guide. The fact control under movement of automatic turn coordination, yard directing, and other limiting rudder training. The fact also computes the limits of the flight envelope. So the limits of the flight envelope is there. Provide the speed information known as the characteristic speed. So all the speed information also is calculated. That is projected in airspeed indicator in the PFD. The FAC also provides computation for the following safety: auto thrust, sincere warning, and load result. Then schematic diagram if you see. So both the side sticks are connected with the ELAC and this side. Trim wheel, you can see there is a directly mechanical link to the QHS. Then there is a pedal which is connected to the rudder pedal, connected to the ELAC, and there is a mechanical link. It is directed to the rudder. Then different hydraulic systems are there. Three hydraulic systems are there: green, blue, and yellow. Green and yellow are basically, there is a EDP, generator pump, which was right. Whereas blue one, there is an electrical pump. Even that is connected with blue. So here in this diagram, just we have to see the priority, the pitch control, the first one. Which one is first controlling the pitch? I'll give you the diagram. Like pitch control, if you see, the ELAC 2 is the primary surface. First it will control it. ELAC 2 is available, ELAC 2 will be controlling. So ELAC 2 will be controlling the elevators, the green, and as long as green and yellow are the ELAC 2 is working, they will be doing the pitch control. By chance ELAC 2 fails, then it will switch over to ELAC. Suppose I am making a hypothetical situation like if ELAC 2 is failed and blue system is low pressure. One hypothetical condition could be possible. So if ELAC 2 is failed and blue system low pressure, then the next priority. So second. Our ELAC 2 and ELAC 1 both fails, comes to SEC 2, next SEC 2. Auto pitch stream, ELAC 2 fails, ELAC 1. डिस्कशन हो रहा है तो मैं भी बात कर सकता हूँ. Same sequence. Mechanical pitch control. Mechanical control of the pitches is available for the piston wheel at any time if either green or yellow hydraulic system is present. And which is the control surface which are having supplied by all the three systems? Hydraulic system. This is not required. You can go through. This is also available in the FCOM. So the same thing we discussed now. First write in the sequence. The LAC 1 to LAC 2 to LAC 1 to SEC 2 to SEC 1. THS. The leading edge of the horizontal stabilizer is trimmed up or down to provide pitch trim. The THS is a much more active part of the pitch control system than on many other aircraft surfaces. When a pilot or autopilot commands a pitch change, pilots to change the pitch value, if you give any inputs, the elevator is easily moved to provide the commanded pitch. So elevator will move accordingly for that particular pitch value. If the desired pitch altitude requires the elevator to remain displaced, if we want that 4 degree has to be maintained, so it has to be displaced to that 4 degree. THS movement is commanded until the elevators are centered with the stabilizer. So basically, it will move the THS accordingly to maintain the 4 degree. So the system will maintain the 4 degree picture. If we need 4 degree picture or some pitch down altitude, so the moment we give, so it will move the THS accordingly to maintain the 4 degree. That's what it is. It is not necessary for the pilot to manually pitch trim the aircraft. So the complete pitch trim, you don't, as a pilot, you don't have to do it. Automatic trimming is available in flight unless multiple failures. If there are no multiple failures, if normal condition is there, then the automatic trimming action is there. So it will be through the THS is going to occur. Then pitch trim system is there, notch up and nose down. The THS uses a screw jack. So wheel is there, on a screw it is moving. A screw jack to raise or lower the leading edge, either you can raise or lower, either direction if you move. If a leading edge of the THS is positioned to a negative angle of attack or tail down. So basically tail down. If you are doing a tail down or negative, lift is produced. So lift is produced, so your aircraft surface is basically tail down. This is shown on the ECAM flight control page as the value will be there, like 0.6 up. Here you can see that is it is upward. Similarly for down up. Roll control, which surface does the roll control? So LRAR is there and they are connected with the only set LAC also. So in the roll control, pitch control, the primary was LAC 2. Roll control, the primary is LAC 1. If LAC 1 fails, so LAC 1, so it will go to the LAC 2 and then SEC. In SEC, if you see, different sets are there, 1, 2 and 3, and they are controlling different sectors. Speed brakes. Number 2, 3, 4 are the speed brakes. In flight spoiler 2, 3, 4. Roll control as a priority. 2, 3, 4, 5 is the roll spoilers. If flaps in config full, speed brakes won't extend. If extended, speed brakes will go. So basically, if config full is there, you will try to extend, it will not. If it is already extended, it will be. Speed brake extension is inhibited. Some of the conditions where the speed brake extension is inhibited, like SEC 1 and SEC 2, 3 both are possible. If you see the previous diagram, no? SEC 1 and SEC 3. So SEC 1 is controlling which one? 3 and 4. And Sec 3 is control. Huh? 2, 3, 4 is speed brake, so it is not control. An elevator is faulty in case of 3 or 4 are inhibited basically. Angle of attack protection. Angle of attack means when you were very high angle of attack, you had a certain value. So high angle of attack means your speed will be in lower. Isn't it or not? There is a possibility of alpha floor also. Alpha floor कुछ होता है? क्या? See. Oh. So basically, in that condition, we don't want that more drag, means the reduction in the speed further. Isn't it or not?
Yes.
So that's why in that case also, when the angle of attack protection is active, is the system is configured in such a way it will be not inhibited basically. Flaps are in config full, already we discussed. Thrust levers are above MCB position and alpha flow is active. So all these conditions, these speed brakes are inhibited. If an inhibition occurs when the speed brakes are extended, so they will retract automatically and stay retracted until the inhibition condition disappears. The speed brakes can be extended again 10 seconds or more after the lever is reset. When a speed brake surface on one wing fails, one side if it is fails, symmetrical speed brake surface on the other wing is eliminated. So the system doesn't want to make any asymmetry. Only one side surface will be active, so that will be create some problems. So it's better to enable. If you see the rest of the things, but number 1 is not connected with anyone. Spoiler number, ground spoiler number 1 is not connected with. So how do you check whether it is active or working or not? So there is a provision for the maintenance crew only. For maintenance purpose, the speed brake lever will extend the number 1 surfaces when the aircraft is stopped or ground. On ground, it is stopped. Whatever the slide flap configuration, any slide and flap, it will for the engineering use. During their maintenance work, they will cross check whether it is working or not. Just to cross check, they will check the flap and lever position. So the one will be also. Speed brake control, the maximum speed brake deflection. One thing I forgot in the morning, because all these information for one particular aircraft, echo delta delta. So that's why I have not mentioned anywhere the aircraft and anything, because this PPT is customized for the aircraft echo delta delta. Okay, so we are discussing only and in the EGRT, this extended ground recurrent learning exam will be based on purely on the EDD. So you have to refer, when you are referring FCOM, if you are referring to OLB, okay, straightforward that number will be there. But if you are referring from MDM, then you get the serial numbers, different serial numbers. So I think 4212 is the serial number for that. So you have to stick to that page only. So max speed brake deflection in manual flight is 40 degree for 3 and 4 and 20 degree for 2. If autopilot is engaged, it is 25 degree for 3 and 4 and 12.5 for pilot. There is a provision. Maximum speed brake deflection achievable with the autopilot engaged by obtaining by setting the speed brake lever to halfway position. Even the maximum not. If my autopilot is engaged, I am giving it only half, still 25 I will get it. Then from half to full, if I am doing it, I am not, there will be no efficiency because already I am getting the speed. For these surfaces which perform both roll and speed brake, roll function is required. When the sum of a roll order and a simultaneous speed brake order on one surface is more than the maximum deflection available in flight, the symmetric speed brake on the other wing is retracted until the difference between the two surfaces is equal to the roll order. So basically it will try to adjust the overall weight. Arming, how will do the arming? So pilot arm the ground spoiler by pulling the speed brake control lever up into the arm. There are certain conditions when it is extended. Full extension. In case reject takeoff. If the ground spoilers are armed, you have armed the ground spoilers and the wheel speed is exceeds 72 knots. It is more than 72 knots. The ground spoilers will automatically extend as soon as both thrust levers are reset to idle. From reverse to idle when you reset. So basically two conditions. My ground spoiler is armed, my speed is more than 72 knots, my reversers are set to idle. These are the conditions when it automatically. In case of reject takeoff. If the ground spoilers are not on, by chance the pilot is smaller, still the protection is made available. How? Ground spoiler will automatically extend as soon as the reverse is selected on one engine. The other thrust remains at. So the moment one reverse you are changing, the reverse is selected on one engine, automatically that also the logic is there. There is something went wrong, that's why you are using the reverse. Otherwise in takeoff phase, what is the use of reverse? Is there any use in the takeoff phase? No. So the system is configured in such a way, if by chance the pilot has forgot to arm the ground spoiler, still under this condition, the speed brakes will be on. In landing phase, again the ground spoiler will automatically extend when following. First is the lever, brake lever is retracted position or ground spoiler is armed. Both main landing gears on ground. The moment both landing gears has to be on ground, both thrust levers at or below idle position. So either idle or below. Or reverse selected at least one engine and the other thrust lever below executed. So basically this is a condition, nothing more than means you are either approaching to land or maybe cross landing. In the crosswind condition, if one side is touched down, other side is not touched. There could be possibility. That also it takes care. So under these conditions, it will retract. Retract or extend. Sorry. Speed brake lever is the retracted position. By chance they forgot, the pilot has forgotten. Still the protection is there. When both main landing gears on ground and reverse selected at least one engine and the other thrust lever below engine. So the moment reverse is selected, speed brake. Ailerons are fully extended aileron entry group provided one aileron servo controller is available on this side. The ground spoilers are fully extended, flaps are not in wing config, pitch altitude is lower than and flying manually in normal orbit. So that these conditions ailerons are fully. This is now the condition of partial extension. So far we discussed for the reject takeoff full extension and for landing phase also. In order to accelerate the full spoiler extension, the phase lift dumping function allows the ground spoiler to deploy with a reduced deflection when the following condition. So there is a provision for phase lift dumping phase wise. So some partial extension procedure is there. The first condition is when the speed brake lever is in the retracted or the ground spoiler is on. One main landing gear on ground. So either one of the main landing gears is on ground, both thrust lever at or below idle. In that case, the partial extension. Second is by chance if the speed brake is not on, still one main landing gear on ground and reverse selected at least then also. In order to reduce the bounce severity at landing in case of inappropriate thrust lever handling during flare, ground spoilers are also partially deployed when following conditions. Ground spoilers are armed, both main landing gears on ground, both thrust levers at or below plant position. Okay. Retraction. The ground spoilers retract after landing when the ground spoilers are disarmed. So either you disarm, then automatically you do. After a resultant takeoff when the ground spoilers are disarmed. So if you correlate this with the normal first condition when the full extension was there. If the ground spoiler was not on, then it will extend, but the reversal condition when you change to the normal idle position, then again it will extend. Whereas this is automatic. The moment arming and disarming you are doing, it will automate. And even if there is a touch and go operation, then at least one thrust lever is advanced about 20 degree. So touch and go means you are using almost either flex or the toga power. So you will be advancing more than 20 degree. So in that case also, it will be. Yaw control. So what are the computers controlling the yaw? Fact. That's some of the information fact gives to the ELAC also. So basically fact and only one is active. Is it or not? So the yaw damping and turn coordination functions are automatic. The ELACs compute yaw orders for coordinating turns and damping oscillation and transmit them to the fact. In computing, but it is giving you the fact, and fact is actually controlling. Rudder, there is a mechanical, direct mechanical linkage. The rudder pedal, you can control. Rudder actuation. There are three independent hydraulic servos. Jacks are there operating in parallel that actuate the rudder. In automatic operations, yaw damping and turn coordination, a green servo actuator drives off and servo drive. A yellow servo actuator remains synchronized and takes over if there is a fatigue. If by chance the green system fails, or green system low pressure, then the yellow system will take over. There is no feedback to the rudder pedals from the yaw damping and turn coordination. So that is pure mechanical rudder, there is no input is coming. Feedback is not coming. The relationship between the side slip, rudder deflection and rudder pedal travel, regardless of the aircraft speed. Therefore, the maximum rudder deflection, full rudder pedal travel remains available. Whatever the speed, full rudder pedal deflection is available. However, except at low speed, maximum rudder deflection is achieved before reaching maximum rudder travel. So there is a limitation also. Even for taxiing also, we'll see when we'll be taxiing with the help of nose wheel steering. There is a handle for nose wheel steering and there is a rudder pedal also. Both the things, by using both the input parameters, we can maneuver the aircraft. But there is a certain angles. See, at low speed, my nose wheel steering will be more. Whereas at high speed, my rudder, though the angle will be very less, 6 degrees. Rudder trim, in normal operation, so there is a motor, two motors are there. So motor 1, number 1 controlled by fact 1, powers the trim, and fact 2 with the motor 2 remains synchronized as a backup. So basically, this is controlling. But the second one, as a standby, it is ready. In case the failure is there, it will take over. In manual flight, the pilot can apply the rudder trim with the rotary rudder trim. The selector was there, the rotary rudder trim selector. The pilot can use button on the rudder trim panel to reset the rudder trim to 0. So if you want to reset it to 0, you can reset it. Two electric motors, the same thing is there. I don't know. Some of the, I say if you see only one single hydraulic, suppose green system is not amber color, green amber. If all the three, green plus blue plus yellow hydraulic pressure go, there is a rudder position and then there are limits. High speed and low speed, the range is changed. Rudder travel limit. The maximum rudder travel deflection gradually reduces as the speed increases. The moment our speed is increasing, the movement limit will be reduced. To avoid, why? Because to avoid the structural damage, to any structural damage, if you, there is one more thing, like VMCG. Have you gone to the VMCG system? What is VMCG? Why minimum? Why not maximum? Yes, because you for the directional control, the rudder has to be effective. If your speed is 10 knots, That rudder will not give you that moment. Means that momentum is required for the directional control. So that's why they define the minimum. Okay, if you reach this value, after reaching this value, any further increment is beyond these values. Suppose it is 113. So at 114, my rudder will be effective to make the correction. In the case of a failure that causes loss of rudder travel limit system, the rudder deflection limit is stopped at the last level. So suppose the system fails, so wherever it was at the last position, it will be over there. At slight extension, full rudder travel limit will be unleashed. In all cases, the available rudder deflection provides sufficient yaw control within the entire flight envelope. This includes in case of maximum asymmetric thrust. Asymmetric thrust is nothing but a pure one engine phase. Then some of the laws are there. Flight control laws. The manufacturers, the Airbus have some built-in laws or the computer instructions for the flight control movement, for the flight characteristics, and then there are certain aircraft limitations. So when they combine all these and then they made some flight control laws. These laws are basically limit the computer authority. Whatever the computer, when you are giving some input, that computer, that particular computer will act based on the requirement. Establish priority. Even there is a priority setup, which is like roll spoilers are there. So roll priority is over these speed breaks. So first the roll inputs will be low, then the speed breaks. Adhere to the safety parameters. Then there are certain load factor limits are there. Like in D, one value is there. When the slats are extended, there is a different value. So it will protect within the envelope. It has to be or VMO is MMO speed limitations are there. So you have to adhere to the safety parameters. Provide backup capability also. So in case of one failure, the other will take over, and there is a backup system available for it. These instructions cannot be modified by the pilot. There is no way that as a pilot I can modify these. These are already configured and systemized, or it is fed into the system in similar manner. Okay, these are for normal control, these are the values will be available for alternate, these are the values for direct law, these are the values will be available. So there are four major flight controls: normal law, alternate law, direct law, mechanical control. Normal law. The fly-by-wire control law is in use when all or almost all aircraft systems are operating. So when everything is working fine. So basically we are in normal. This is the flight control law is used during normal operation. So if nothing is wrong, everything is fine. We are in normal. The aircraft flight envelope is protected and is automatically limited in pitch, roll, minimum max speed, G and angle of attack. So it takes care of everything. Load factor, angle of attack, pitch, roll, yeah, everything it takes care. No single failure of aircraft system will result in loss of command. Even the system are so much robust that if a single failure happens, it will not lose the normal law conditions. Still in a single failure, even one engine fails, still it is in a normal law. Alternate law. Alternate law is automatically in operation following multiple failures. So more than one failure, this will lead into the alternate law. The aircraft flight control surfaces, hydraulics, electric power supply, sensor, or anything. It could be because of any combination of failures. It maintains the high level of fly-by-wire capability. We will try to maintain the whatever the basic requirement of the fly-by-wire. Though everything is not available, but at least some protections will be available. Then comes to the direct law. Direct law automatically in operation following more significant. If there are a number of significant failures are there, it will go to the direct law. It maintains the lowest level. Now this is the condition where the almost close to the, almost not the complete, almost close to the conventional. There is a direct relationship between the side stick position and the control surface. So basically there is no control at all. direct law, any controls are there? No controls. Only manual trim is available. Then mechanical backup. This law occurs when all flight control computers fail. This is nothing but a conventional type. Everything has failed. All flight control computers are failed, or in case of total loss of electrical power. The computers are working, but there is no power. So in this law, side sticks are also in order. Aircraft is controlled with manual pitch trim wheels, rudder paddles and engine thrust. Purpose of this law is to control and maintain the aircraft control until the higher level. So there is a difference in the TFT speed. Use man pitch trim only. There are two things. What is the difference? So in which case it is direct law? Use man pitch trim. So means you have to, for pitch trimming, you have to use the manual. Whereas man pitch trim only means there are no flight control computer, nothing is working. So that is mechanical backup. So normal law, there are different protections like load factor, pitch altitude, angle of attack, high speed, bank angle, low energy, load elevation protection. This basically is different. Load elevation function is not there in this aircraft. Since some of the generic slide I have prepared, that's why it is there. Otherwise, for this particular aircraft, load elevation protection or load elevation function is not there. You know, from different aircraft, that protection is not there. So remember, this will not be there for this particular aircraft. So there are different modes: ground mode, then flight mode, then flare mode, then again ground mode. Pitch, normal law. Again, the ELAC is there, direct elevator deflection or manual trim selection. Ground mode is a direct relationship between side stick deflection and elevator deflection. So basically, the ground when whatever the input you are giving, it is going directly to the input. The THS is automatically set at 0 inside the green band. However, when the flight crew enters manually, told you during the takeoff, when with the trim seat, only is increasing. That time is increased. Setting to adjust the CG, this is one has priority for the takeoff. Then pitch normal law, ground mode. During the takeoff roll, up to 70 knots, speed max nose up is limited to 30 degree and max nose down is limited to 15 degree. Above 70 knots, it is reduces further from deflection from 30 to 20, and this is in order to reduce the tail strike at nose. So basically up to 70 knot, there is a 30 degree, and then in order to avoid the tail strike, they reduce further. Then flight mode, the normal law flight mode is a load factor demand. So the moment lift off, after lift off the ground mode, reaching certain height, suppose you attain the V2, sorry. V2 is speed. So the moment you attain that, beyond that you will be continuing that. So that flight mode will start. So here it is now based on the load factor. Load factor G is what? What is lift by weight?
Yes, sir.
Okay.
Yes.
मैं बीच में उल्टे भी बोलता रहता हूँ, तो हाँ करने के पहले आप एक बार सोच लिया करो फिर बोला करो, ठीक है? So basically it is a load factor. So the moment flight mode comes, it will be basically from the load factor demand mode. And automatic trim and protection throughout the flight. For the flight mode, full protection will be there. Following normal law, the side stick controller set the elevator and THS to maintain load factor proportional to side stick deflection and independent of speed. So irrespective of speed, stick movement, based on the requirement, the flight control computer works, takes feedback and everything accordingly to maintain. Side stick neutral position of our. With the side stick at neutral, wings level, the system maintains 1G in pitch, corrected for pitch altitude, and there is no need for the flight crew to trim by changing speed or control. If you are given, there is no need to you are changing. Therefore, the flight crew only need to perform minor correction on the side stick if the aircraft deviates from its intended flight path. Once you have given certain value, it will maintain auto trimming. If auto trimming is available, it will maintain that. If the flight crew senses an over control, the side stick should be released. If it is, though there are certain restrictions, even if you try to put full forward or full backward, still with the protection it will restrict you to the certain value. Automatic pitch trim, no back pressure required. So bank 33 degree. So flight mode, we have seen that it is purely on the load factor demand. Automatic trim and protection throughout flight. Automatic trim is there. Side stick controller set the elevator THS to maintain load factor proportional to the stick. 1G they are maintaining. No need to change the pitch, and it will back up to 33. So basically it is restricting you to certain value 30. This trim is automatic both in manual mode and when autopilot is limited. So now like this, the flight mode is active from takeoff to landing. So here now the side stick is pulled. When it is pulled, it will maintain. You have pulled, you will leave it. It is maintaining that pitch altitude. Till the time you further give the input. Once you reach at the climb level, you have to speed first. Then it will maintain that. So since the auto trim is available, it will trim it. Side stick is used only when you want to change the altitude, not for maintaining the altitude. Only when you are changing, not to maintain to 4 degrees, 6 degrees, I have to maintain, no. Only if you want to change from the level flight to the climb. If you are climbing up, yes, you are giving some. Or you are descending down, putting it down. Automatic pitch trim start from RA greater than 15. Automatic pitch trim freezes when you choose manual pitch trim through the pitch trim. If you select it manually through the pitch trim, it will freeze. RA less than 50. So basically the flare mode starts. 100 feet with the AP engaged. If the autopilot is engaged, the value is 100 feet. Load factor goes below 0.5 G. The aircraft is under high speed or high Mach progress. Under these conditions, it will freeze. Automatic pitch trim will freeze. Nose up trim freezes only. Nose down trim is available when angle of attack protection is active. Again the same concept. Nose up, why they have freezed? Now again if you are going up, your speed is going to reduce because energy is common. You will try to utilize that energy and that will compromise with your speed. So in order to protect that, says nose up trim they have freezes. Load factor is higher than some value, 1.25. Aircraft exceed 33%. That these conditions only nose down are available, not nose up. When high speed or high Mach protection is active, THS setting is limited between the setting and the aircraft entry into the protection. Control with autopilot engaged. The ILACs and SIPs limits what the autopilot can handle. The flight crew has to overcome a restraining force in order to move the side stick when the autopilot is engaged. So basically, what you are doing is you are overcoming. You are coming out from that autopilot. Isn't it or not? Side stick when the autopilot is engaged. If the flight crew overcomes this force, the flight crew disconnects the autopilot. Disconnect side stick से कहीं कर सकते हैं कि नहीं? Autopilot.
Yes.
So red color button is there या blue color button?
Red.
So that is priority. And why it is given over there? It is very easy. You are there. Instead of going on the glare shield or switching off the AP, with the hand itself, the stick you are using for most of the movement you are using the side stick. So there is first priority is the hand stick. You can disconnect the autopilot. The flight crew can also disconnect the autopilot by pushing on the rudder pedals 10 degree out of it. When rudder pedal then 10 degree out of it, or by moving the piston wheel beyond a certain threshold. All protection of normal laws remains effective except pitch attitude protection. Flare mode. So when the aircraft passes 50 feet RA, 50 feet RA, if you correlate this with the performance, that your speeds, approach speeds are calculated, or the landing distance are calculated once you are 50 feet above threshold. From there, you are coming down, touching the ground, applying all braking means stopping the aircraft. So that is the flare start from the 50. When the aircraft passes 50 feet RA, the THS is projected. Okay. And the normal flight mode changes to a flare mode as the aircraft descends to land. Flare mode is essentially a direct stick to elevator relationship. Again, in the ground mode, we have seen that in ground mode, direct relationship was there. In the flare mode also, direct stick to elevator relationship with some damping provided by load factor and fixed rate feedback. The system memorizes the aircraft attitude at 50 feet. So the systems are configured in such a way, whatever the attitude at 50 feet was there, it will register or it will memorize. And it becomes the initial reference for pitch attitude. So that will be your initial reference for pitch attitude. As the aircraft descends to 30 feet, the aircraft begins to reduce the pitch attitude to -2, completely nose down, and over a period of 8 seconds. Consequently, the aircraft has gentle nose-up action by the pilot. Okay. So at RA, 50 feet RA, it will memorize. And the moment when -2 degree nose down, then you have to a bit nose up attitude is required. If I go around, in case go around, something went wrong and you have to make a go around. So if a go around is attempted below 50 feet, is it possible below 50 feet you can do a go around?
Yes.
Any condition?
Reversals are not.
Reversers are not.
Below 50 feet means taxi. Isn't it or not? Only in case of auto-led valve. When we are unable to do automatic landing, then only. Otherwise, normally, before DH, if everything is went wrong, right, then only you will proceed to land. Even if automatic landing warning is not there, then you continue. But by chance, something went wrong, some accident, and you have to make a go around. So flight mode thereof, auto trim could not be restored until reaching 50 feet, because the auto trim is the moment you reach 50 feet, it freezes, there is no automatic trim. And more than normal pitch force may be required to pull up the aircraft up to and maintain the go around attitude. So basically at that period of time, reach the go around attitude to 50 feet, you have to pull up and you have to maintain that. Because now if you leave, it will not restore, because the automatic trim is not there. It will try to, the moment you leave it, try to come back. So you have to pull up, and if some directional control left or right also, so that also you have to maintain. Again, upon touchdown, elevator deflection is again restored to direct elevator relationship. 5 seconds after touchdown, the THS automatically resets to zero. So normal law protection, general, the normal law protect load factor, pitch attitude, high angle of attack, angle of high speed protection. So with the side stick and you see the elevators on these protections, load factor, high speed, pitch attitude, high angle of attack, high speed. Load factor. There is a defined value. Green config -1G to +1.5G, and when the flaps are extended, 0 to 2. So that is one flight envelope that defined by the Airbus. Okay, our flight will be going between these in all the phases of flight. Load factor protection. High load factor can be encountered during evasive maneuver due to potential collision. By chance, like we are taking off from an airfields where the terrains are there, and one engine fails. And then there is a, while controlling, there is a possibility that terrains are there, so we have to maneuver a bit, excessive maneuver. So those are the cases where they seek it, the high load factors. Maybe we need a high load factor just to avoid the tail. Isn't it or not? So pulling G is efficient if the resulting maneuver is really flown with this G number. If the aircraft is not able to fly this trajectory or to perform this maneuver, pulling G will be detrimental. So basically, normally with this endurance, most of the airfields, because wherever the terrain or other things are there are different procedures are there. Engine out seat. If the airfield is advanced, engine out seat will be there. Or as a airline, we have to define the procedure in case of engine failure. What is the procedure after takeoff? If that airfield is critical, you have to develop the procedure after takeoff with engine failure. This after takeoff means during the takeoff. From V1 to any point, takeoff is remains up to what level?
1500
feet. So basically from V1 to 1500 feet, if something went wrong. So what the action we are going to do? So that is defined. Okay, we will be going to sitting there hitting this one and climb up to this level and all. Based on the obstacles. That's why in normal in any area for the commercial aircraft, we are not flying the jet aircraft or the fighter plane, where these maneuvers could be very different. Because only the pilots are there, and then whatever maybe ammunitions will be there. The purpose of that is different. Here the purpose is safety and the passenger comfort is also. You cannot make it complete world 360 degree of the commercial aircraft. I think Dubai airspace 4 years back I think. When 380 was going and decided that one small aircraft was there. Because of big paper. That happened. Okay, so there could be, so but luckily there was no casualty or any problem out there. But that is not mean for that. We are not mean for that. Our limits are fixed. So that's why on most commercial aircraft, the potential for an efficient 2.5G maneuver is very remote. We are not going up to 2.5G. Rarely we are good. In emergency situation, initial PF action on a side stick is hesitant then aggressive. First, if you are in a panic, you try to be aggressive, but then you will do a excessive. In panic situation, there is a possibility. With load factor protection, the PF may immediately and instantly pull the side sticks full off. The aircraft will initially fly at 2.5. The moment it is full off, it will go to max value, whatever the limit is there. 2.5G maneuver without losing time. Because first the computer is there, computer is getting the demand and my limit is 2.5, so I will take it to the max value without thinking twice. I will straight away go to the 2.5. Then if the PF still needs to maintain the side stick because the danger still exists, then the high angle of protection will. Now, the moment the pilot has given the input, still he is putting it up to this level. He has pulled up completely off and still he is maintaining, trying to maintain. Then the angle of attack will also come into the picture. The protection will active and load factor protection enhances this with high angle of attack protection. This load factor protection enables immediate PF reaction without any risk of overspacing there. Because if you have come out from that condition, okay, if you are still in that condition, then no issue. But if you come out from that condition, it's better to reduce it. So there is no requirement to maintain 2.5G. Because you are unnecessarily stressing the aircraft, over-stressing the aircraft. So, flight experience has also revealed that an immediate 2.5G reaction provides larger obstacle clearance than a hesitant and delayed high G load factor. Because immediate requirements, now the terrains are there immediately, so you get some margin. So there are obstacles ahead of you. You are taking off from Leh, Kathmandu, Kalighat, Lengpur. There are certain airfields where the terrains are there. By chance, tailwind condition, one engine fails, some extreme condition, gust is also there. So there is a possibility this could happen. So in that way, immediately if you do, immediately you will be negative. Because you are still away from the upside. So that's why any airfield, it is customized in such a way, normal operation is, if anything went wrong, you still will be able to maintain. Pitch attitude protection. Excessive pitch attitude caused by upset or inappropriate maneuvers lead to hazardous situation. Too high nose up, very rapidly energy loss. You nose up, so energy will be lost. Again the speed will be lost, angle of attack will be increasing. So alpha floor will be active, isn't it or not? Too low nose down. Again, the speed will be high speed protection will come into the picture. There is no emergency situation that requires flying at excessive altitude. For these reasons, pitch attitude protection limits pitch attitude. Because normally flying in commercial aviation, there is no requirement to go to the extreme limits. So pitch attitude protection limits the pitch attitude. 30-degree notch up, config 0 to 3 progressively. First 30 degree and then it is reduced to 25 degree at low speed. For config full 25 degree reduced to 20 degree. 15 degree nose down. So 30, 25. Config 0 to config 3 reduced to 25 and 25 reduced to 20 and nose down to anyway 50. And then the symbol equal to symbol is there on the PFD, green color symbol. The flight director bars disappear from the PFD when the pitch attitude exceeds 25. The moment attitude is more than 25, bars will go off. They return onto display when the pitch angle return to again between 22 and 10 degree down. So any value more than 25 pitch up or 30 degree pitch down, that bars will go off and they will come back once the pitch up is 22 degree, pitch down is 10. In normal law, the aircraft is protected against stall. This protection is also effective in dynamic maneuvers or gust when the current angle of attack becomes greater than alpha prop. The high angle of attack protection includes. What is alpha prop?
Angle of attack protection.
Okay. So what are these values? What alpha floor, alpha max, alpha CL?
Angle of attack.
Can we reach up to alpha CL max? Normally, if alpha floor is active, so we cannot go up to that, but we can go up to what level? Alpha max. Beyond alpha floor, still will keep. So the speed is going to reduce, angle of attack is going to reduce. Your alpha floor will be active. Now the moment you release the side stroke, it will restore to the what value? Alpha. Because the alpha floor is active. Thrust limit को change होगा या नहीं होगा? So the angle of attack can further be increased by flight crew. There is a VLS alpha floor. But still, if I am putting aft side stick, the angle of attack can further increase by flight crew input up to a maximum value equal to alpha max. Alpha prod has crossed, but still by using that it will go to max value of alpha max. When the high angle of attack protection is active, the normal demand is modified and the side stick input is an alpha. Angle of attack demand instead of a load factor. So now it will switch over. From the load factor, earlier it was in flight mode, it was load factor demand. It will go to the angle of attack. The flight crew must not deliberately fly the aircraft with high angle of attack. Until unless it is required. You are not going to use this high angle of attack. Except for short period of time when maximum high lift coefficient is required. Maybe for certain period of time some maneuver, means here some maneuver, pull up, some massive coming in the newer ways. So when maximum high lift coefficient is required, V alpha prod, V alpha floor, V max are mainly computed based on the angle of attack. All these values based on the input, angle of attack they calculate, and therefore they vary with the configuration weight and load factor. So depending upon different config and weight, it will change. The angle of attack will not exceed alpha max if this protection is active. The aircraft is normal loss. So at any point of time, your speed is not going to reduce or your angle of attack is not going to increase beyond alpha max. Even if the flight crew gently pulls the side stick or the wing. So the protection will be, it will restrict you to alpha max. The flight crew can hold full back side stick if it is needed and the aircraft is stabilized at an angle of attack close to but less than 1 G. Why it is not allowing you further? Because the moment if you exceed this value, there is a limit for alpha CL max. Beyond that, the condition of stall will come. Aircraft is going to avoid this stall, this protection. When flying at alpha max, the flight crew can make gentle turns if necessary. If the flight crew releases the side stick, the angle of attack returns to alpha prop. The moment he or she release the side stick, it will automatically come to alpha protection and it stays there. As the aircraft enter protection and the amber and black strip alpha prop, that barber pole, the system indicates further nose down, nose up trim. So nose up trim, it will freeze. There will be inhibition. Nose up trim is not possible. Beyond that point already reached. The nose down trim remains available. There is a possibility of nose down trim. The high angle of attack protection has a priority over all other protection. The aircraft can also enter alpha prod at a high flight level where it is protects the aircraft from the buffet boundary. Buffet boundary again that reason that 1 to 2.5 and 0 to 2. Like low speed or low flight level, if the side stick is simply released to neutral, the aircraft maintains the alpha for alpha prod. The moment side stick is released, it will stick to the value alpha prod. Therefore, when leaving a turn after entering alpha prod, the aircraft will climb with the side stick free. Alpha for alpha prod is reduced, not required. So, between the alpha prod and alpha max, alpha floor protection may automatically center go around. So the moment you cross alpha prod and you are alpha max in between somewhere, or you reach the alpha max, so alpha floor will be activated. The moment alpha floor is activated, in the FM link, you will get the message alpha floor. The alpha floor will usually be triggered just after entering into the alpha. The moment you enter into alpha protection value, so alpha floor will be active, are triggered, and the go around thrust will automatically be applied. So go around thrust will be applied. Therefore, if the side stick is held off either inadvertently or deliberately, the aircraft will start to climb at a relatively constant low rate. So now the aircraft will start to climb just to come out from that angle of attack. To recover a normal flight condition, the alpha prod should be executed by easing forward and side stick, and the alpha floor should be cancelled by using the stick to disconnect the run on either thrust lever as soon as the safe speed is. So can the alpha floor be automatically come out from that condition, or we have to do something? So basically, to exit alpha floor protection, push side stick forward. To cancel toggle lock, then there is a condition called toggle lock. Means the power will be lock and toggle active. So what you have to do? You have to
unlock.
On the thrust lever, so head clear push it, or auto thrust. From there also you can autopilot from there. Auto thrust or autopilot. So there also you can display. Autopilot. High speed. Aircraft automatically recovers flying if you are going to a high speed protection. Basically VMO MMO कितना है?
350.82.
350.8. When the high-speed protection is activated, the THS setting is limited between setting the aircraft entry into the protection and 11 degrees over. When high-speed protection is activated, positive spiral static stability is introduced at 0 degree bank angle instead of 33. Normally it was 33 degree, now it is restricted to 0. So that when the side stick release, the aircraft always returns back to 0. The moment you it is 0. The bank angle limit is reduced from 67 to 420. So basically, the range of positive spiral stability in case of high speed protection, rolling maneuver is limited to 0 to 4. Bank angle. Inside the normal flight envelope, positive spiral is bank angle above 33 degrees. So basically, if you see 30 degree, where the pitch trim is there, wherever you leave, automatic pitch trim. Beyond 33, there is no pitch trim. So during a normal turn, bank angle less than 33 level flight, PF moves the side stick laterally. The more the side stick moves laterally, the greater the resulting roll rate. It is not necessary to make a pitch correction because pitch trim is automatic. It is not necessary to use the rudder. In case of steep turns more than 33, now automatic pitch trim is not there. Lateral pressure on the side stick to maintain the rudder. Now we have to hold it over there to maintain because automatic trimming is not there. Off pressure on the side stick to maintain the level. Aircraft trimming. When the aircraft is normal cruise range, is so a reconfiguration of law from normal law it goes to the alternate law. Alternate law, there are two things: with protection, without protection. By seeing this screen, you can identify which one is the normal law, which one is the alternate law, which is the direct law. Normal law you can see, whereas in alternate law it is number process, and in direct law alternate law. In some double failure cases, normal law is not achieved in alternate law takes. Pitch same as normal law but with less protection. Roll direct to side stick deflection. Yeah, only yeah damping reduction. Alternate now with protection. Load factor limitation will be there. क्या हो? देखिए. Low speed stability. Here the low speed stability comes into the picture. Artificial low speed stability reduces the normal angle of attack protection. It is available for all flat flap configurations. The gentle progressive nose down signal is introduced. The pilot can override it. Then high speed stability. It is similar to that normal law. Alternate law without reduced protection. This is identical to alternate law except that it does not include the low speed stability. So here the low speed stability will not be there. Rest of the things.
High speed also.
Direct law. Is there any protection available in direct law? So direct law, everything is pitch direct to side stick, roll direct to side stick, yaw direct to rudder. No protections. Mechanical backup. Mechanical backup enters the pilot to control the aircraft during a temporary complete loss of electrical. So pitch available only via the manual pitch trim. Yeah, for the rudder. Side stick will work or not? Then this you must be looking at the priority, how the priority is going over. And who takes over. In case both the pilots are giving the simultaneous inputs, what are the discussions going on? If you are not interested, you can go out of the class. In case of simultaneous inputs on both side stick, the two green side stick priority, lights on. So green color, that side stick priority lights will come, and in the glare shift, dual input voice message will also be. And in slats flaps, here one thing when is the wingtip brakes activated?
Runway.
So basically runaway, overspeed, uncommanded demand, all those things. So the first one, the wingtip brake, which activate in the case of an uncommanded movement of the surface, such as runway, asymmetry or overspeed. They cannot be released in flight. Once activated, cannot be released. They use blue and green hydraulic power for the slats and for the right wing flaps, and blue and yellow hydraulic power for the left wing. There are two messages. One is slats locked and another is slats locked. Slats locked alert trigger when the wingtip brakes are activated in flight due to slat asymmetry. Whereas fault alert triggers when there is a failure of both slats channels. Both the channels are failed, then the slats fault. Otherwise, when because of asymmetry, runway condition between WTPs are activated, slats lock condition. This is also one of the important alpha speed lock function. So this function enables the slat retraction at high angle of attacks and low speed. The SFCC use corrected angle of attack and airspeed information from the ADB to inhibit the slat retraction. There are certain conditions. Suppose the flaps lever is set to 0, means you are from 1 to 0 you are moving. The slats alpha speed lock function activates and inhibit slat retraction when the speed is less than 148, and the message will come alpha lock. The legend is pulses in green when the slat alpha speed lock function is activated. So basically, if it is already set to 0, then this will not come. When you are moving it from 1 to 0, then it will the condition. When the aircraft is on ground and the speed is less, no, that entry is not there. Means this one. Once the slat alpha speed lock function is active, the slat retract to 0. When? So basically, what is happening? When you are setting the flap lever to 1 to 0, that case, if there is an alpha speed lock function will activate when the speed is less than 148, and then there will be indication as a alpha lock. The message will be pulses green will be indicated. This too you must be knowing. And please go through some of the failure and normal procedures from the AFCOM. Okay. So this concludes the flight control. Take a break and then we will continue.
So one doubt. Which all failures, if you could like summarize, because there are a lot of failures.
Okay, after break I'll come then. Otherwise next day I'll